Hi, I'm Corey Wade, and I will be your instructor for the Machine Learning Masterclass. I'm really excited about this. It's going to be a great course. This is my opportunity to show you all the best that I have to offer when it comes to machine learning. First, let me go over what the class covers generally. There's actually a range of topics, but I'll name a few. There's Pandas. So Pandas is Python's data analytics library. And in particular, we're going to look at how to transform null values and categorical columns so that your data is ready for machine learning. We're not going to spend a lot of time on Pandas. This is not a class on Pandas, but there will be an introductory lesson on Pandas to ensure that everyone is on the same page. Next, this is fun. We're going to look at the evolution of machine learning algorithms. ML, by the way, stands for machine learning, with a focus on decision trees. So we're going to look at decision trees, random forests, gradient boosting, and extreme gradient boosting. We'll also start with regression so we can see, how the transitions are made. Now that brings us to actually the next focus of the course, which is XGBoost. So XGBoost stands for extreme gradient boosting. We're going to spend a lot of time coding XGBoost in this class. In fact, XGBoost, you could say, is the overall focus of the class. And you'll see why. It's usually the best model on average when it comes to making predictions using tabular data. That's data with rows and columns of numbers contrasted with unstructured data like images and text, where deep learning usually is better. So one thing we'll look at in particular is fine-tuning hyperparameters. This is a big topic, and XGBoost has a lot of hyperparameters. I will also say that the hyperparameters of XGBoost are actually found in a lot of other machine learning algorithms like decision trees, random forests, gradient boosting, AdaBoost. A lot of tree and ensemble-based parameters will be found here. You'll get good at fine-tuning hyperparameters. This is a key topic that distinguishes beginners from more seasoned practitioners in machine learning. After that, we'll look at some advanced topics in machine learning. And, we'll cover a reasonable amount. Starting with how about variance versus bias? This is a big topic. It's kind of the finesse of, overfitting and underfitting, finding the right balance. And we'll look at that. We'll also look at imbalanced data very carefully. So imbalanced data leads to different scoring metrics, and we'll use the classification report and the confusion matrix to get there. We're going to look at speed, which is a pretty cool topic because, well, one, XGBoost is designed for speed, but also when we get to really large, it's big data, but then there's bigger data, you could say. We're talking like billions of entries or more. Speed matters. And so we'll look at different ways to time and compare the speed of models. And we'll also look at Kaggle tricks. Now, this is a lot of fun. So Kaggle is where XGBoost developed its great reputation. Kaggle competitions are where machine learning practitioners compete against one another to try to generate the best possible models. And XGBoost has won its fair share of Kaggle competitions. We'll look at some tricks like stacking and non-correlated ensembles that Kagglers have used to rise above the competition. Okay, so who is this class really for? It really is for two groups of people, okay? If you've had a class in machine learning, you are in the right place. Class in machine learning. If that's the case, this is a great second class. It's going to go into a lot of depth. And I'll also say this though, it's not technically required because I will be teaching machine learning from the bottom up. So on that note, it's also okay if you are proficient in Python at the level of implementing new libraries with dot notation. And I'm going to say at a comfortable level. So Python comfort with new libraries. And the libraries that we'll be using include scikit-learn, it's a big one, Pandas, and NumPy. So I would say that covers the gist of it. I'm really excited about the class. I look forward to seeing you in the interactive videos. One final note, this class is largely based on my own research of a book that I wrote, Hands-on Gradient Boosting with XGBoost and scikit-learn. So you even will have that as an optional text that you can use as you go through this course to cover some topics in greater detail. Thanks, and I look forward to seeing you in the videos.